permeable drugs, while immediate release formulation is useful for the drugs which have faster dissolution than the absorption. And most of the times when you try to develop modified release formulations, that is the scenario. That is the kind of drugs that we would try to develop modified release formulations. So the drugs with limitations on the solubility and then permeability, oral solution is the best. Now there are more sophisticated software programs available that incorporate PBPK modeling also. But in our scenario, so if we select IR formulation, and then we can also sometimes have access to the innovator data, you could easily take the data and use it for the pilot study, if not for the pivotal study. Pivotal study, it is always recommended to have reference data within the study. Moving on to the correlation analysis. Now we have fraction dissolved and then fraction absorbed. You would like to look at the exploratory plots of fraction absorbed versus fraction dissolved, or LAV plot, TVO versus TVTRO. This is the most important plots. So these plots will let us know whether we need to apply or account for time scale differences in time for dissolution and then in vivo dissolution time. So if they are different considerably, we may have to account for T scale. But if you observe any lag time, you have to account for the T shift in the model. And then app scale accounts for the differences in the absorption. And the app space is very important, especially when you have a hormonal product and then you also have an endogenous hormone present. So you may want to account for the app space. So once we have scaling parameters for both time and then shifting parameter for the absorption, you could select one of the built-in models, or you could built-in equation. You can write your own equation or develop a